Hello, my name is Pracheth and welcome to my channel. In this video tutorial, I'm going to show you how to program this microcontroller by Nuvoton. Its part number is W78E052DDG. So this microcontroller has got many interesting features. It's similar to other 8051 based boards like 8089C51, 8089S51 or P89V51RD2. So these are all the microcontrollers which you can directly replace with Nuvoton microcontroller. The pin diagram is same in all these microcontrollers. This has got 4 ports, 4 8-bit ports, 3 timers. Okay, this is additional timer you get, one watchdog timer, one UART. It has got everything that a microcontroller should have, but it's 8-bit, right? And it's 8051 based, so it will not have SPI and ADC or other such features that advanced microcontrollers have. But it's a good microcontroller to begin with. So let's get started with this. If you're someone new in microcontroller programming, learning C program, embedded C, then this is the board, this is the chip you should start coding with. You don't require any development board. That's what I'm going to show you today. All you need is this components, okay, and breadboard and some wires, and you can make your own development board. And depending on the interfacing devices, so today we are going to blink just one LED. So I have used a LED, green LED with 470 ohm resistor in series. So depending on the interface device, you can connect it to a breadboard. You can use a larger breadboard. Why to buy a development board? You can make one using these cheap components. So I'm going to show you today, and also I'm going to show you how to write a program and upload it using a laptop. In addition to this, you require this programmer FTDI module, which is called FT232RL, which is a USB to serial converter. So these two, you will also require some jumper wires, okay, female to male. So this is the RX, TX and ground, okay. This is also called USB to TTL module. This chip on this is called FT232RL, and it has got a USB connection so that we can program it. Connect this to the USB. Other end we can connect it to the laptop. This is detected by our COM port, and the software, the flash software that we are going to use to burn the program in this chip is provided by Nuvoton for free. And just all we need to do is generate hex file using Keil. So I'm going to show you that later. So let's first make the circuit, okay. So let's see what all components we are going to need. We need some mini breadboard along with some breadboard wire, single core, one LED with resistor, this Nuvoton chip. This is also a very reasonably priced board. I got it only for 100 rupees from Robu. And this is a switch. This is a 10K resistor, okay. This is a capacitor of 10 microfarad, electrolytic capacitor. This is 10K resistor, one 16 megahertz crystal oscillator, 247 picofarad capacitors. So this will form the crystal oscillator circuit, okay. This is for the reset circuit. This resistor is to make the external access pin high. This is the switch, reset switch, okay, which goes with the reset circuitry. And this is the LED that we are going to interface. So let's make the connections. The circuit diagram is given in the blog, link is in the description. I will make the connections and come back. So now all the connections are made. I've connected the LED in current syncing. In current syncing, we connect the cathode to the pin, okay, such that when we give 0 to the output 0, the LED will glow, So one side is always given to high. Giving 0 will turn the LED on and giving 1 will turn the LED off. The external access, the memory, we need to access the internal ROM. That's why we have to keep this EA bar pin high, okay, through a 10K resistor. This crystal oscillator, and this is the reset switch circuitry, and I connected the switch so that when I press the switch, plus 5 volts will go to this pin, high will go to this pin, and it will reset this chip. Now all we need is to connect the RX and TX, okay. So this one is the RX, okay, we'll go to the TX like this, which is besides the reset, and TX will go to RX, okay. This is ground, which will go to the ground. This is not giving power to this board. This is just, so that's why we are giving only ground common. This is just to upload the program. It will connect to the computer, but it will not draw power from the COM port. The power is drawn from the adapter, okay. So this is the adapter output, 5 volt will get here. So this is positive, which will go here, okay, and negative will go here on the power rails. So right now the power supply is off. I have not turned it on. I've actually uploaded a blinking code previously in this chip, so let us see whether it's activated or not when you turn on the power. So yes, the blinking code is there. Because previously I uploaded a blinking code in this chip. I have not erased the flash memory, but it also we can do. So now I will change the blink frequency to some another and then upload the code again, just to show you that how to upload the code in this chip. So now I've connected the TTL module to the laptop's COM port and we are ready to upload code in this chip. The RX and TX wires were wrong. I referred the pin out. I swapped the RX and TX now. Now TX is going to RX and RX is going to TX. Okay, so now we are sure that the code will get uploaded. So the code is written in Keil IDE to blink the LED. I'm using a simple for loop delay. Okay, so I will explain you the code now. So how to generate a C file in Keil IDE, how to create a project. The detailed steps are given in the blog, link is in the description. Now I'm going to just explain you the code, okay. So first we include the register51.h library. We define our LED to which pin it's connected. It's connected to pin 0.1, okay. Then this is a delay function prototype. Then in the void main, initially we turn off the LED because it's in current syncing. So as I told you, in current syncing, if we give 1, you output high, the LED will turn off. And now we enter the while loop. Now in the while loop, LED is turned on. Then there is a delay of 500 milliseconds. Then again LED is turned off. Then there is a delay of 500 milliseconds. And this loop repeats. So we see a continuous LED blinking. And this delay function is very interesting because it has got 2 for loops. So this for loop runs for 500 times, okay, that we pass in this delay function. That means 500 times this for loop runs for 0 to 163 counts. So 163 counts is for 1 milliseconds. If you increase this from here, for a single count, that much delay you will get, okay. So this is the general delay function. Now what I will do is I will reduce the delay, okay, to 50 milliseconds. And I will click on this build. And you can see here in the build output, it says creating hex file from objects, 0 error, 0 warning. Now our hex file is created. Now all you need to do is upload the hex file using the Nuvoton ISP ICP utility software. So when you open this, the COM port is detected, okay. If we select this bullet ISP by COM port, and our COM port is detected, you have to select the chip. So our chip is W78E052D. Now to load the hex file, all you need to click on load file and browse to the path where our hex file is stored, and then click on open. So the hex file is now loaded in the AP-ROM buffer. So now let's click on update chip, and you can see detected 805. You have to instantly reset it, otherwise it will not work. So now it's erasing the EEPROM, and yes. So as soon as we click on this OK, the board will be automatically resetted and our code will start running. You want to see? See. I will zoom out a little bit. Now I will hit on OK, and the code starts running. You don't need to reset it. That's the beauty of this ISP utility software by Nuvoton. So the reset happens in the software side. And you can see that the LED is blinking at a rate of 50 milliseconds. So the TTL module is removed now, and I powered it on again. The code is running, the LED is blinking with 50 milliseconds. So in this way you can upload code in Nuvoton's 8-bit chip. Please let me know in the comments if you want to learn more about this microcontroller, timers, interrupt UART. There's much more to learn. I'm going to make video on each of these topics, and also I will make it more interesting by making it a project based learning. Okay, so subscribe to my channel for more interesting electronic videos. Like this video. Thanks for watching.